Hi everyone, this is the second part in our chi-squared test for independence video series. What we did in the first video is we determined that we investigated whether there's a relationship between an individual's gender and their movie preference. We conducted a hypothesis test using StatCrunch, or any stat package actually works. What we found is that the p-value was less than 0.0001 when we set that up, and so we concluded that there is indeed a relationship between gender and movie preference for all individuals based upon these data. We then started to dive a little deeper into how this works. And the chi-squared test statistic is based on the expected counts and the observed counts and how they differ. Observed is actually what you actually observe in the data. Expected is what you would expect if there was, essentially, if the null hypothesis is true, if there was no relationship. And the formula you need to calculate expected values is expected count equals the number in the row times the number in the column divided by the total number in the table. Now, the chi-squared statistic, that's a tongue twister, is given by the formula chi-squared equals the sum of observed minus expected squared over the expected count. The sum means you're going to do that for each cell. There's 8 of them in this case, or 10, You're going to have 10 values, and you're going to essentially find observed minus expected squared over expected for each cell, and then add up those 10 values. If you look at StatCrunch, when you do that, you're going to get a total of 51.98. All right, or 99, 51.99. Now, the way the chi-squared test works is if there is no relationship, then observed and expected should be about the same. You see that in the table above with male and comedy, for example. And male and comedy, about 24 males were observed to prefer comedy. 23.62 were expected to. So if there's no relationship, then observed and expected will be about the same. If there is a relationship, then observed and expected are going to be essentially quite a bit different. So if the chi-squared statistic is close to 0 or small relative to the sample size, then there's no reason you would fail to reject. It means there's no evidence of a relationship. If the chi-squared test is a whole lot bigger than 0, then you would reject. That says there is some evidence of a relationship. Now, how do we find that test statistic? We're not going to do all of it by hand, but I want you to know a little bit of where these numbers come from. Let's find one cell, how it contributes to the chi-squared test statistic. You take, say, comedy and male. Okay, that's 24 observed minus 23.62 expected. Square that and divide by the expected count, 23.62. That equals, let me do that in my calculator, 24 minus 23.62, square that, and divide by the expected count of 23.62. So that cell itself contributes very little, 0.006. Okay, 0061. That's how much that the comedy male cell contributes to the total chi-squared test statistic. All right, now let's finish this up. We have determined there's a relationship. If a relationship exists, then that doesn't mean that every cell in observed is different than every expected cell. But it means somewhere in this table, the expected and the observed counts are quite a bit different. Now, the way you take that next step and say, okay, well, which one? Where is the difference? Which ones are different? What you need to do is look at what's called the percentage error. And the percentage error, this is one way. There's actually several ways to do this. This is the way I prefer. The percentage error is the percent of essentially the percent of difference between the observed and expecteds. So the percent error is given by the formula observed minus expected divided by expected. Then you've got to turn that into a percentage times 100%. So, for example, male action. We observed 61. So for male and the action genre, observed 61, but only 40.94 were expected. How far off? What is the percentage error in that of what was observed versus what was expected? You would take the observed, 61 were observed for male and action genre, minus the expected, 40.94, divide by expected, 40.94, and that equals 0.4899, okay, or 48, actually, when you round up, it's actually 49%. That means that among that male action, about 49% more males than expected preferred the action genre. For females, so this is 49%, and notice it's a positive, positive means that it is more than expected. So we get 49%. Okay? Now, positive 49%. Notice I've done the others in red. For female, the expected is observed, 17, minus expected, 37.06, over the expected, 37.06. That equals negative 54.13% when you turn it into a percentage. So among females, 54.13% is negative, fewer than expected preferred the action genre. Okay, so I've got all of the percentage errors listed in red in this table. What is it? What is it overall? We've already concluded via the hypothesis test that there are some differences. What you need to do now is simply look through the table and say, what are the differences that are particularly large? Sort of the threshold that I use is more or less 10%. If the error is under 10%, then it's not particularly significant. If it's over 10%, then it is pretty significant. Now, there is some trade-offs. That's not an absolute rule, but because you have to consider sample size and so forth. But this is a good rule of thumb. So what we would need to do is identify the differences in the table, those that are over 10% error. So we already did the first one. We looked at the male in action. So okay, in the action genre, so for the action genre, 49% more males than expected. Preferred action movies. While 54.13% fewer females than expected preferred action. So in general, males, what that says is males tend to prefer action movies, at least according to these data, more so than females. What you would do for your overall conclusion is you would go through each of these categories. And like I say, you don't need to identify every single difference, but the ones that are particularly large. I might also do, for example, what's the one where there's a fairly large sample? Drama movies. Okay, so what does the data say? It says that among this is a negative, sorry, among so within the drama category, 64.47% fewer males than expected prefer drama movies, whereas 71.18% more, since it's positive, females prefer drama movies. So that I would just write for the conclusion, go through these data, look at the percentage errors, and identify 2 to 3 that are particularly large. The last part of chi-squared statistic, as we did with all of our tests, is determine whether the procedure is valid. So we've already examined whether sort of calculated the observed counts. We calculated the expected counts. We go back and looked at expected. I think it was expected was 40.94 and 37.06 for these two. So 40.94, 37.06. All right. So the validity conditions for the chi-squared are pretty straightforward. Number one, you have to have a random sample of individuals or moviegoers. And if you look back at the problem, it said you did have a random sample of moviegoers. And number two, it's pretty straightforward. You say the second condition is only two, is that the expected cell count in each cell must be greater than 5. So in our case, our expected counts are in parentheses. So the expected counts in each cell are greater than or equal to 5. All right. So because both of those conditions check, our validity, our chi-squared process, our chi-squared test for independence is valid.